Alright, we have mentioned when we read the data from disk to the main memory, we have to assign a data block or the record with a unique main memory address, right? However, when it comes to a real-world data loading, we will meet many of the unexpected problems because sometimes inside the data records or blocks, there may also exist some internal data references, right? In other words, for a data record, we may refer to some other data record, or we can also refer to some other data blocks as well. Then how can we handle this kind of problems? How can we handle this kind of address? Because we mentioned before, for the data record, if we are loading them to the main memory, shall we also replace this kind of references with a new main memory address or not? This is the problem we are starting this page. It's called pointer swizzling. So this swizzling means the replacement. If we need to replace this pointer with a new address of the main memory or not. And the process of replacing a physical or logical pointer with a main memory pointer is called pointer swizzling. And we may need to translation tables such that the subsequent references are faster. In other words, we have to create a translation table to translate these kinds of pointers from the physical or logical pointer to the main memory pointer. What does this mean? At the bottom, we show an example. Let's assume in the disk we have two blocks, the block 1 and the block 2, right? And inside block 2, we have several records. We have record 1 and record 2. However, for record 2 inside it, we have one pointer referencing to the record 1 in the same block as shown here, right? So this pointer denoting a reference pointer. At the same time, this record also referring to another record in the block 1 as well. So there will be also another pointer, right? No matter this pointer denotes a physical pointer or the logical pointer, it doesn't matter here. So we are referring to some other record with a pointer. However, once we are loading the record into the main memory, right? We are loading it into the main memory. We know we will assign this block with the main memory address. Then the problem will be, how about these kinds of pointers? How can we handle them? There are different ways, right? The first way is we just ignore them. We're still referring to the original address in the disk. If so, then we can keep this pointer. Here we have this record, right? It is referring to this record in the disk. In other words, we still keep this pointer unswizzled, unreplaced, right? So it is still referring to the record in the disk, right? Here is here. However, if we decide, right, for this record, it has been loaded to the main memory, and if we still referring to the record in the disk, it will be a problem, right? Because sometimes we may make some changes to this record. Therefore, a better way is we can replace this pointer before we are pointing to this record in the disk. If we don't change or that doesn't replace it, we still may need to refer to this one, right? However, if we decide, say, we change this reference pointer pointing to its new address in the main memory instead. In other words, we can referring to this record we have in the main memory, right? This is called this swizzled pointer. This one is called unswizzled pointer because this one still referring to the record in the disk, and this one referring to the record in the main memory instead. By replacing this physical or logical pointer with the main memory pointer instead, right? So when we move a block from a secondary storage space to the main memory, the pointers with the block may need to be switched and translated from the DB address to the main memory address. It means we have to translate this address from the DB address to the main memory address instead, just as shown in the example we show here. We're replacing the original pointer. This is this physical logical pointer in the disk. However, once we load it into the main memory, we have to replace this pointer to the main memory pointer instead because we have both records in the memory right now. This kind of pointer swizzling is very interesting. Also, sometimes can be complex. And we have to decide a strategy how to replace these kinds of pointers and when we need to do the replacement. Of course, there are different strategies we can use to handle this pointer swizzling. So the first kind of strategy we can use is to use automatic swizzling. It is also an eager strategy. So when a block is read in the main memory, we need to swizzle all the pointers in the block. In other words, no matter where we are referring to, we replace all the pointers with the main memory. This is how to say. This is very eager, right? Another one is we can use some on-demand strategy instead. In other words, we leave all the pointer unswilled when the block is first brought into the memory and then swills only when the user requests. It's kind of a lazy strategy, right? Compared with the eager one, as shown here. We can even have a more lazy one, which is no swizzling at all. So we will always use the translation table to translate the pointer to the concrete physical address instead. If so, then we may need to organize the translation table. In other words, we can be able to know if we're referring to a physical pointer, how can we refer to the data in the memory, right? We have to organize an external translation table to translate the physical logical pointer to the memory pointer instead. And the pointer are followed by in the unswitched form, and the records cannot be pinged in the memory if so. These are the strategies we can use to handle this pointer swizzling in loading data from the disk to the main memory. So before we mention if we're loading data from the disk to the main memory, we may need to replace the pointers to the main memory pointer instead, right? It is called pointer swizzling. However, if later on we decide to write the data back to the disk from the memory, we may need to unswizz this pointer back to the physical logical pointers instead. So when the blocks return to a disk, the pointers need to be unswizzed. It actually will cause some problems if we don't handle it very carefully, because if we are reading the data into the memory, right, and beside the reference pointers we have in the data originally, and we may also create some external pointers as well, which may point into the concrete blocks or record in the memory. However, once if we are writing this block back to the disk and also do the unswizzling of the pointers, and we may still have some other blocks which are referring to or pointing to this kind of blocks, right? We are writing to the back to the disk. If we do the unswizzling, then the remaining blocks referring to the block in the memory, we're referring to nothing, right? It will be a problem. And so it will be, we need to handle this kind of problem very carefully. One way is we can use this pinged blocks. In other words, we don't allow this block to return to disk if we have some other one which are pointing to the block right now. And we can keep a list of reference to this block very carefully, so we can record if we have any external blocks which are referring to the current block we plan to write back to the disk. If the disk is empty, then we can do this writing as well as unswizzling very safely. However, if we still have any other external blocks while referring to the current block, then we have to wait until this list becomes empty, right? In this way, we can avoid danger because we may always be able to refer to blocks which are existing in the memory right now before we do the unswizzling. Okay, so this is something we need to do if we decide to write the block back to a disk after we do the swizzling we mentioned before.